Okay, now we're recording. I guess I'll make a part two. Although I don't know if it saved the other one, if it cut off right when my computer turned off. I'm not sure, but at least I'll have this. It's doing something weird. Okay, so what I was about to say is summing up uh, enumerative induction. Basically, you want to know this right here, okay? Target group, sample members, relevant property. Okay, that's pretty easy. Target group, right, the whole group that you're talking about. You're extrapolating concerning the entire group on the basis of what? On the basis of samples, sample members. Right? That sample can be a chemical strip in a pool. Right? It can be a survey. It could be anything, any kind of observed instance of a member of that group. Right? The relevant property is the thing that you're interested in, whatever it is that you're talking about. Okay, so understand how every enumerative induction argument breaks down in these terms, right? So that you can keep in mind what's being said, and then that way you can evaluate the argument better. And so when you evaluate the argument, it's really all about understanding the target group, right? How homogeneous the target group is, and then understanding how many sample members you probably need in order for it to be representative. And you need to make sure that you're interviewing or collecting random sample members rather than a specific group where the results are likely to be skewed, right? So, vocabulary wise, concept wise, this is what I want you to know. Target group, sample members, relevant property, then things like sample size and representativeness, right? Those are the two things that really count when you're evaluating this type of argument: the sample size and the representativeness of the samples. I'm not going to ask you to really understand or talk about margin of error or confidence level. Okay, I included those just to be complete, but you won't be tested on those, and I don't think you need to know them. But you should know, in general, how these types of arguments work, right? The right terminology to use, and then understand what makes them work and what makes them not work. And that all has to do with the samples, right? You have to have enough samples, and you have to make sure that they represent the overall thing, okay? So really I think, yeah, it's all about representativeness and sample size. So the really simple example, again, is a small pool versus, let's say, a very large lake, right? A very small pool, it's very homogeneous. You probably don't need to have that many samples to understand what the overall chemical composition of the pool is. But for a large lake, you're probably going to need a lot more samples, and so you need the right sample size. And also, you can't just get all your samples from one side of the lake, right? You have to get those samples from different spots all around the lake randomly so that you're getting a good representation of the lake in general. Right, so I think the lake versus pool example really brings to light those things: representativeness and sample size, right? Okay. And so the less homogeneous something is, the larger your sample size will have to be, and you also have to really make sure that your samples are representative of the whole, right? So if you're testing a lake, test different spots all around the lake, not just this one little corner, right? Whereas if it's a pool, maybe just one corner is fine, right? Okay. So then, let me get into one more thing, and then we'll be done. Oops. We are now on analogical inductive arguments, analogies, arguments from analogy. I personally think arguments from analogy are really tricky. I don't I don't particularly like them. It's hard to know when your argument from analogy is good. It's almost always better just to translate it into an enumerative argument. Anyway, sometimes they make sense. And it's, again, the same kind of thing. I won't exactly be able to give you a procedure. It's rather there are certain things you can keep in mind when you're evaluating analogical arguments. Basically, analogical arguments say, well, here's a set of things that, they share all these properties, so they're likely to be similar in other regards as well. That's basically how those kinds of arguments work. So, the example we already looked at is in medical testing, right? Chimpanzees are very similar to us biologically. So then if we give them a certain drug that treats a certain kind of cancer, and we have the same kind of cancer, and the chimp gets better, well, it's a very good chance. It's not guaranteed, of course, and that makes sense. This is an inductive argument. But it would stand to reason, it would make a whole lot of sense that maybe it would treat a human being as well. You see how this is an analogy, right? Humans are enough like chimps, biologically speaking, to conclude that if a certain drug works on them for a certain kind of cancer, then it probably does for us as well. Of course, it's probably, right? There's always a chance that it's wrong. But the whole idea of medical testing relies on this inductive kind of reasoning, where there's a higher likelihood that we'll have a good chance. Or more controversially, if we get into more philosophical areas, right? People use this argument quite a lot. This is a famous kind of argument for the existence of God. The philosopher William Paley, hundreds of years ago, used an example similar to this, but he used the watchmaker, or used the watch rather, right? You conclude that a watch had a watchmaker, so you can conclude that other things that seem to have complexity and design must have had a creator. Well, here it's like that, right? You might say, well, computers are very intricate, complex systems, and they're put together in such a way as to achieve the purpose that they have as conceived by their designers, right? Computers have all these functionalities. They do all these cool stuff for us. Why? Not just random, right? Somebody designed all these features, designed all these programs. Well, human beings are like that too. Human beings have intricacy, complexity, and purpose. There's all sorts of stuff that we can do. So human beings must have been designed by a designer, right? It's a popular argument. Now, I don't think this argument is right, but again, these are always just examples, right? It's an example of an argument by analogy. It's saying, well, basically, when you find complex, apparently designed things, they must have had a designer, because they are like other things that are complex and functional in this very complex way, where it had a designer. So in other cases, it's also going to have a designer. It's an argument from analogy. You see how it works in basically the same way as the first example works, and it works basically the way that the definition I gave up there tells you it works, right? Or here is definitely a bad one, right? Number one is pretty straightforward. It's a pretty good example. Number two is definitely an argument from analogy. Is it a good one? Well, some people say yes, some people say no, right? Number three is obviously pretty bad, right? Birds have 2 legs, 2 eyes, they breathe air, and they fly. Well, humans have 2 legs, 2 eyes, and they breathe air, so probably humans can fly. Now there we realize that does not work, right? It's an argument from analogy, but it's an extremely weak one, right? Yes. So the very first one, not that controversial. 3 is extremely bad. 2, I'll leave it up to you to decide. But what they all have in common is that they are making comparisons between cases, right? Saying, well, this has these features and this special feature. this over here has all these features, just like this one does. Therefore, it probably has that feature as well. Right? That's how these arguments work. So what makes an argument from analogy a good argument, a strong inductive argument? Well, first of all, the similarities that they have to be relevant to the property in question, right? The more relevant similarities the comparison groups have in common, the stronger the argument. So, for example, drugs that's only been tested on mice versus a drug that's been tested on humans. Which drug would you rather take, right? If you had a deadly disease and there's been this drug that's been tested on mice and it's been successful at treating the disease, but it's also been, but here's a drug that's been tested on humans that's treated the disease successfully. Well, humans are more similar to you than a mouse is, right? Now, mice have lots of relevant similarities, right? They do. Mice have lots of relevant similarities. They're mammals like us. They have a cardiovascular system and a brain and a nervous system. They have to breathe air. They rely on nutrients that they get from the environment. All sorts of relevant similarities to human beings. But notice, other human beings are more relevantly similar to us than mice are, right? So a drug that's already undergone human trials is much more reliable and much more predictive of success than a drug that's only undergone mouse trials, right? You see the difference? Humans have more relevant similarities, right? So we're comparing, basically our comparison groups are humans that have been tested in the past successfully with this drug, right? And now me here with being treated with the drug, am I likely to have the same outcome as those other members of the group? Well, yeah, because they're just like me, right? The similarities are very strong, and they're definitely relevant, right? Whereas between mice, there's not, and human beings, there's not as many relevant similarities. Okay, does that make sense? Did I do that too quickly? Okay. Well, the basic idea, right? If we're using this as an example, which would you rather, right? Which do you think is going to be more reliable? Right? If you are the person who is sick and you have a drug that's been tested on humans and it's been successful, it treats the disease in those humans. Now, will it treat the disease in you? Very good chance that it will, right? It's been very successful on other human beings who are very much like you. Very high chance of success in that case. As opposed to, let's say they've only tested it on mice. There's lots of relevant similarities there, but obviously not as many as there are between you and another human being. Right? So how predictive is the success that this medicine had with the mice on the success that it will have with you? Well, not quite as strong, right? Not quite as certain. Not entirely certain in either way, but it's a much better chance that the drug will work if it's already been proven to work on human beings rather than just on mice. Okay. I mean, we could look at other examples, but I'd like to try to get done, so maybe it'll become clear with this one. Relevant dissimilarities are not good. Right? The more relevant dissimilarities the comparison groups have in common, the weaker the argument. Right, so for example, I'll give another example, but if we go back to the mouse example, right? There's lots of dissimilarities between human beings and mice, right? There's lots of dissimilarities between me and a mouse that are relevant. For example, mice are much smaller, right? They might have a different type of immune system. There's lots of things that are dissimilar between me and mice, whereas there's not as many relevant dissimilarities between me and another human being. There'll be some dissimilarities. Right? There's some genetic disparity. There's all sorts of other confounding factors, but on the whole, we're a lot closer to one another. Right? There's less dissimilarities that make a difference. Yeah. They're relevant dissimilarities, right? It has nothing to do with things that are irrelevant. For example, maybe tails don't matter, right? Maybe that's not a relevant dissimilarity when it comes to a certain kind of brain cancer, right? Maybe tails just don't matter. Maybe that's a similarity that's irrelevant. But there are lots of relevant dissimilarities between human bodies and mouse bodies, right? So that would make it weaker. Here's another example. Let's say first we have a somewhat stronger. I'm going to compare two different cases, okay? So you can see this idea of dissimilarity. So first, a pretty good example, a pretty good argument. Say Jessica, Tom, and Paul, they're all siblings, right? They grew up together. They all have college degrees and well-paying job. Oh yeah, they also have a sister named Joan who has a college degree. I don't know what she does, but I bet she's got a well-paying job as well. Pretty good chance, right? I mean, it's an inductive argument, so we can't know for sure. But, if you had to guess, I'd probably guess that rather than the opposite. I still, you can easily go have a college degree and not get a good job. But, their siblings got good jobs, so all these things sort of conspire together to say, well, it's much more likely that Joan also has a good job. Right? Okay, well, regardless of how good you think the argument is, compare that argument with Jessica, Tom, and Paul, all siblings, have college degrees and well-paying jobs. Their sister Joan does not have a college degree. Does she have a good, well-paying job? I bet she does too. Right? You might say, well, because all Joan's siblings have good-paying jobs, so she's more likely to have a well-paying job. True, but that argument is not as strong as the first one, is it? Right? Out of these two arguments, the one where Joan has a college degree, just like her siblings, the conclusion is much more warranted. It's a much stronger argument, right? Because there are dissimilarities here, right? Joan, yes, there's one similarity. She's a sibling, just like they all are. But there's a very relevant dissimilarity, right? Namely, having a college degree. That's relevant because we know having a college degree does correlate to some extent with income. Right? So this is a relevant dissimilarity. It matters that she's dissimilar in this way, and that makes the argument weaker. Right? Whereas when the similarity was when there was a similarity, a relevant similarity, the argument was much stronger. Right? The case where Joan was both a sibling and had a college degree, there the conclusion is much more warranted. Right? It's a much stronger inductive argument because there are more relevant similarities. Whereas in the second example, where she doesn't have a college degree, right, she's different from her siblings, there are relevant dissimilarities that are making the argument weaker. Yeah. So in this example, in the red text and the blue text, right, the red text is a much stronger argument than the one in the blue text, because the one in the red text has relevant similarities, whereas the one in the blue text has relevant dissimilarities. Yeah, okay. And some things are irrelevant, right? For example, their hair color might make no difference to it at all, right? Maybe it does, but that could be an example of a irrelevant similarity. Yeah. And then finally, how many numbers of cases are being compared, right? The more examples we have to look at, the stronger the argument is going to be. So here's a simple example, right? You've heard one song you like by a particular artist. Let's say you've only heard one song, but you think you might like more of their music. Does that ever happen to you? Is anyone into? I love music. I'm a music person, and I love going on Spotify and finding new artists and stuff like that. That's a lot of fun, right? So sometimes you hear a song and you think, "Oh, this is a new thing that I'm going to listen to. I just know I'm going to love all their stuff." Sometimes that's true. Sometimes it's not, right? So it's it's an inductive kind of argument. You hear a song and you think to yourself, "Oh, I might like some more of their music." Okay, but what if you've heard like a dozen songs by this artist? You've already heard a lot of their songs, and you think, "Boy, every song you hear by them I like. I bet you I would like the rest of their catalog as well." A much stronger argument, isn't it? You have a stronger case for your conclusion that you're probably going to like their other music as well. If you only heard one song versus a bunch of songs, that's all we really mean here, right? This is an argument from analogy because that's the way we think about music, right? You think, well, this song has all these elements that I like. This song over here is by the same artist, right? So they are likely to have all these things that I like as well, right? You have a much stronger case to make that claim when you've actually heard lots of songs that all have those relevant features, those relevant similarities that you like. If you're already familiar with a band's catalog, it makes a lot more sense. You have a better ability to predict whether or not you will like their other output. That's all that really means. So it's a little bit similar to having a larger sample size, right? And I sometimes think that analogical induction, you could probably just convert it all into enumerative induction. I sometimes think we should just get rid of analogical induction altogether. Yeah. But we do this kind of reasoning in everyday context. We argue from analogy, right? And so here, it's 1:30, so it's a good stopping point. For analogical induction, this is what you have to keep in mind. It's all right here, right? So I just summarized enumerative reasoning, right? What you look at there. Here, what you look at is the relevant similarities, the relevant dissimilarities, and then how many cases are we looking at? Yeah. Okay, we can be done for today. Then we have next week. We have 1 week left, and we'll talk about causal reasoning. Okay, causal inductive arguments, and that will segue also into arguments to the best explanation. Okay.